I wanted to go through a couple of practice problems on Le Chatelier's principle and some of the decisions you will have to make. Number one, it's not asking about which way it's going to shift, left or right, forward or reverse reaction being favored, although that does play a part in here. The questions here are a little more specific. So in number 1A, increasing the concentration, remember that's what square brackets mean, of CO will cause the concentration of H2 to do what? So we go up here to our equation. These all are gases. And if I increase CO, I inject some more into that system at equilibrium, add shifts away. So the reverse reaction would be favored. So that means I've got CO and H2 combining to produce more products. That means that the concentration of H2 is going to go down. More of it is going to be used up with the additional CO to form that CH3OH. So the concentration of H2 would decrease. All right, and then in B, let me get rid of these. All right, in B it says that raising the temperature will cause the equilibrium of the system to shift to which direction. So our heat is here, and if we read the forward direction, it says that we have methanol plus 101 kilojoules of heat will combine to produce carbon monoxide and hydrogen gas. That means that the forward reaction requires heat to go forward, so the forward reaction is endothermic. So when you increase the temperature of a system, the endothermic reaction is favored. So the forward reaction would be favored. In this case, it would cause the system to shift to the right. All right. And then in number 3, raising the temperature will cause the value of K to do what? Well, since they're asking about K, which is our equilibrium constant, could be Kc, it could be Keq, or just very simply K, we need to go ahead and write the equilibrium expression. So K equals products over reactants raised to their coefficient power. And when it's at equilibrium, you may wonder which are your products and which are your reactants. Well, it does depend on which way you look, but they always mean considering the forward reaction. So the forward reaction, our products are CO and H2. Now this would be that H2 has to be squared because of the coefficient there in front of H2. Those are my products over my reactants, and my reactant is just methanol. And that is my equilibrium expression. So increasing the temperature is going to favor the forward reaction because we already determined that the forward reaction is the endothermic reaction. That means that the value of CO is going to go up and the value of H2 is going to go up because the forward reaction is favored. That means I'm going to be making more products. The value or the concentration of methanol will go down. So if I have things on top going up, getting bigger, and the number on the bottom getting smaller, what's going to happen to K? It is going to increase. Now remember that K is a constant. It is the equilibrium constant for that reaction, so it's always the same unless we have changed the temperature, and that's what we did here. All right, now going over to the next problem. It's a little more shifting which direction type questions. So, in the next problem, it says we have this equation here. Which way will the equilibrium of the system shift? The left, right, or neither direction? So if I add extra CO as in A, if I add, it shifts away, so the reverse reaction would be favored, or the system will shift to the left. All right, now a catalyst is introduced. Catalyst just makes reactions happen faster. So that means both the forward and the reverse reaction would both happen faster, so nothing would happen to your equilibrium. It is just going to stay the same. All right. Now in C, it says the temperature of the system is lowered. If temperature goes down, that means that the exothermic reaction would be favored. If temperature goes up, the endothermic reaction is favored. If temperature goes down, the exothermic reaction is favored. So we want heat to be produced. So if we read this reaction in the forward direction, we have water combining with carbon to produce carbon monoxide, hydrogen gas, and heat. So our forward reaction is exothermic, so the system will shift to the right. And then our next question has to deal with pressure. Oops. And pressure just deals with the moles of gas. Now we only have a few of those. Let's see, water vapor is a gas, carbon monoxide, and hydrogen gas are both gases. So we only want to look at those particular things when the question is about pressure. So the pressure is increased on the system. So the reaction is going to shift so that it becomes smaller. And so it will shift to the least number of moles of gas. So that means the reverse reaction will be favored because we only have 1 mole, because the coefficient there is 1, for water. And we have, on the product side, we have 1 mole of carbon monoxide and 1 mole of H2. So it's going to shift to the side with fewer moles, and so the reverse reaction will be favored, or it's going to be shifting left. I hope that helps.